Today we are going to have our first kind of official lesson of our new unit dealing with exponents and logarithms, and we're going to spend a decent amount of time with exponents. So we really want to ground ourselves back in the basics, starting with the concept of expanded form. So start off with this key definition. Expanded form is an expression written out using multiplication and without exponents. So let's see how this comes into play with this table below, which you can fill out for me as well. This first expression here, x to the third power, if we were to expand that out and write it out using multiplication without exponents, it would look like this. We'd have x times x times x. Now, you can likely go through and fill out the rest of this table already, but just kind of follow along with me. X to the second power would be x times itself twice, and x to the first power would be x times itself once. Now, x to the 0 power is a special case. That is always going to be equal to 1. Whenever we take something to the 0 power, that's going to be equal to 1. The other special case here is when we have a negative exponent, like this x to the negative third. And what that's going to do is it's going to create a fraction for us, and we're actually going to divide by x times x times x. So we'll set a 1 up top, and on the bottom we'll have x times x times x. That's what's happening when we have a negative exponent, is we're dividing by x 3 times. Then same thing happens when we have x to the negative 2, we divide by x twice. And when we have x to the negative 1, we're going to divide by x once. So we're going to use this concept of expanded form to help us simplify the expression. And yes, I know this might seem like we're doing more work than we need to. If we already know some exponent rules, I understand that we can take some shortcuts. The purpose today is to kind of ground ourselves in what exponents are so that we can build a better understanding for them in our later units. So please work with me and first write out in expanded form before simplifying. So this first one, we have 3x times 5x to the third power. First thing we can do is multiply our numbers together. We get 3 times 5 is 15. And then if we write out in expanded form, we get this first x here. And then we have x to the third power again. That will x times x times x. So this is what expanded form looks like here. Everything's written out. We don't have any exponents. We have it just written out as a multiplication problem. So then if we want to simplify it back together, here's the then simplify step. We can recondense that down where we have x times itself 4 times. So we're going to have x to the 4th power. Let's move on to example 2, and likely you can already start trying this on your own. Rewrite the expression in expanded form first. So we'll have negative 2 out in front. We'll have m times m times m, and then another instance of m times m. All right, and then if we go to our simplify step, we can condense that all back together. We'll get equals negative 2. And m multiplies by itself 5 times. So we'll condense that down to m to the 5th. All right, example 3. This one's starting to get a little trickier because now we have a negative exponent. So let's write it in expanded form first. So we have our 4 times 2 gives us 8 out in front. And then we have w times w times w times w. However, now we have this instance of an exponent with the negative 2. So that's going to create a division problem for us where we get w times w on the bottom as well in our expanded form. So our expanded form takes our positive exponents, w to the 4th, sets them on top, and we'll divide by our negative exponents, w times w. Once we have that, if we're working towards simplifying, then we can cross out any pairs that show up on top and bottom. So there's a w there, w there, w there, w there, and we can get 8 w squared as our final answer. All right, let's really start building with this, building in multiple variables with the negatives as well. So starting with expanded form, we have x to the third, so x times x times x. We have a negative 4 for this y, so let's set up a fraction here. We'll divide by y times y times y times y. Then we have another negative exponent with x to the negative 1, so we'll tack on it times x. And finally, we have this y squared at the end, so times y times y. So that's what our expanded form looks like. So if we move to that simplify step, we can start crossing off any pairs that show up on top and bottom. So it looks like we have an x on top, x on bottom. We have a y on top and bottom, another y on top and bottom. So we are left with 2x's up top, so that'd be x squared divided by y squared on the bottom. So we're going to keep building complexity here. First off, for expanded form, we'll have 2 up top. And then we run into this instance of x to the 0 power. Anything to the 0 power should be 1. So it'll be 2 times 1 to start. We can finish out our top with y times y. And since we have a negative exponent with x to the negative 2, we'll divide by x times x. Then if we look to simplify this, we see that there's nothing up top and bottom that we can cross off. So we can simply combine the 2 and the 1. 2 times 1 gives us 2. Condense down y times y to y squared, and condense down x times x to x squared. And let's do one more example to kind of push our learning even further. And this is going to kind of bleed into what we're working on tomorrow. We have w squared, and we're taking that whole thing to the third power. So if we're writing this out in expanded form, we are going to have w squared times itself 3 separate times. And so if I do that and then expand it out one more time, then I'll have w times w times w times w times w times w. So we can then go ahead and simplify that out, where we ultimately have 6 w's in a row multiplied by each other, w to the 6th power. All right, and to close out our notes here, let's just quickly jot a summary in our own words down at the bottom of our note sheet. How do you write an expression in standard form or in expanded form? And remember that this should be in your own words so you can look back on it later and remember exactly what we did here.